Hello geometry students, my name is Emigh, and this video is our discussion on chapter 10. Title of chapter 10 is Area, and we'll cover section 10.1 in this video. The title is Angle Measures of Polygons and Regular Polygon Tessellations. Starting with the Polygon Interior Angle Sum Theorem. The sum of the measures of the interior angles of a convex N-gon is equivalent to n, then you subtract 2 from that, you multiply that total by 180 degrees. One more before we practice with these. The regular polygon interior angle corollary is that the measure of each interior angle of a regular N-gon is the formula from above, okay? So n minus 2 times 180, but then you divide that by the number of sides. And you guys have actually already worked with this. I hope you don't think it's brand new. You already know how to work with this with a triangle. Triangle would be a 3-gon, polygon with 3 sides. So we would go 3 minus 2 times 180, which is 1 times 180, which is 180 degrees. And that is called the triangle angle sum theorem, where the measures of the interior angles added all up equals 180 degrees. You've also already done this with quadrilaterals. That would be a 4-gon, 4-sided polygon. So that would be 4 minus 2 times 180 is 2 times 180, which is 360 degrees. And we had a theorem that supported that the interior angles of a convex quadrilateral always add to 360 degrees. So it's not brand new, it's just the general form now. You can apply it for any N-gon, and then if you want, if you have a regular polygon, you can divide that result by the number of sides, and that will give you the measure of each of the interior angles. All right, find the sum of the measures of the interior angles of a convex octagon. Okay, we got to start with, how many sides does an octagon have? If you said 8, you got that right. Octagon has 8 sides. So the sum of the angles would be equal to n minus 2 times 180. And in this case, our 8 is our n. So we substitute 8 for n. And then simplify. And we get 1080 degrees. So what that means is any octagon, so an 8-sided polygon, 4, 5, 6, doesn't have to be regular, 7, 8. If you add up this measure, this one, this one, this one, this one, this one, this one, and that one, you will get 1080 degrees every time, as long as it's a convex octagon. Find the value of x in this figure, then use x to find the measure of angle A and the measure of angle B. Okay, we have a geometric figure. We need to translate it into an algebraic equation. You need an equal sign and an x in there. Go ahead and pause this video and try to translate that figure into an algebraic equation and then solve for x. All right, let's see how you did. If you wrote your equation as x plus 20 plus x plus 135 plus 90 plus 125 plus 90 equals 720, you got one accurate equation. There you could have, using the commutative property, added them up in different orders, but nonetheless we set that equal to 720. Where does the 720 come from? Well, this is a 1, 2, 3, 4, 5, 6-sided polygon. We call that a hexagon. So that would be n equals 6. So we would do 6 minus 2, multiply that by 180. So that's 4 times 180, which is where we get the 720 from. All right. Solving that equation, we get x equals 130. And then we can use that to substitute back in, find the measure of angle B is equal to 130 degrees, and A is that 130 plus 20 more, so 150 degrees. All right, the Sino Steel Tower is a hexagonal, honeycomb-looking green building in Tianjin, China. It was designed by Mad Studios architects, and we are asked to find the measure of each interior angle of one of the hexagons. Okay, so we have a regular hexagon right here, and we're asked to find the measure of one interior angle, like that there. Well, they're all the same, just so you know. You guys do know that. Regular hexagons have all of the angles have the same measure. So if we can figure out how many degrees they sum up to, then we can divide that by 6. All right, so let's zoom in. Let's change our perspective on that there so we can get a better look at that octagon. Ooh, hexagon, 6-sided. So we have n equals 6. 6 less 2 divided by 180 degrees. And then each angle can be found by dividing that result by the number of sides, which is why you see the divided by 6 there. Doing some arithmetic, simplifying, we get down to 120 degrees. So that means that every one, this one right here is 120 degrees. This one, this one, this one, this one, and this one are also 120 degrees. So that would be 6 angles measuring 120 degrees each. That is 720 degrees. All right, name that polygon. All right, here are the hints about the polygon. It is regular, and the measure of the interior angles is 144 degrees. Try to name that polygon. Maybe I'll give you a hint here. The measure of each interior angle is 144 degrees. Well, you can write your equation with the number of sides being the unknown variable, and you would set that equal to 144 degrees, and then solve for lowercase n, and if you do that correctly, you'll get down to n equals 10, and any polygon with 10 sides that is regular, we call a decagon. 10-sided, that would be a regular decagon. All right, let's try again. Name that polygon. It is regular, and the measure of the sum of its interior angles is 3,600 degrees. One way to find the name of that polygon is to set your equation equal to 3,600. Notice we're not dividing by n this time. We divided by n because we were told that each angle equaled, or we were asked to find, we were told that the measure of each interior angle is 144 degrees. That's why we divided by n using that formula. But this time we're just told their sum is 3,060, so don't divide by n. Solve that equation for lowercase n, and you should get n equals 22, and that would be a 22gon. Exterior angles. The angles that are adjacent to the interior angles of a convex polygon are the exterior angles of the polygon. And we've looked at this one time before, quite a few chapters back. So just take any side to your triangle and extend it, and you have created an exterior angle, 9. Take this side, extend it, there's another exterior angle. Those two are actually vertical angles as well. 4 and 5 are vertical angles and exterior. 6 and 7 are also vertical angles and exterior angles to that triangle. So the list of exterior angles for this triangle would be 4, 5, 6, 7, 8, and 9. Okay, so let's work with those exterior angles now. This theorem is called the Polygon exterior angle sum, and it says that the sum of the measures of the exterior angles of a convex polygon, one exterior angle at each vertex, is 360 degrees. So notice they're just doing one exterior angle at each of the vertex, okay? But if you add all of those up, you will get 360 degrees. So an example would be the hexagon, which we can see in the figure there. Adding up the measures of angles 1 through 6, we would get 360 degrees. And it's not dependent on the number of sides, okay? It's just 360. For example, let's take a triangle. Let's do one exterior angle here. Extend this side for another exterior angle. And extend this side for our third exterior angle. So if you add the measures of this angle, and this angle together, it'll equal 360 degrees. It doesn't matter if it has 6 sides or 3 sides, or I'll show you one more. 4 sides like this. Extend, 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 extend. And if you add it up, this measure, this measure, this measure, and this one here, you would get 360 degrees every time. Regular polygon exterior angle corollary, and that is that the measure of each exterior angle of a regular n-gon is 360 divided by that number of sides. So you can see from our same example of the hexagon, add all of these up, you get 360 degrees, and then divide by 6, and you get the measure of each of those angles. So angle 1 equals 60 degrees, angle 2 measures 60 degrees, all of them. 1 through 6 all measure 60 degrees. Okay, find the measure of each exterior angle of a regular pentagon. Pause this video and give it a try. Welcome back. If you came up with 72 degrees, you got it right. All of these angles add to 360. That's where this comes from. This is a regular pentagon, so all of those angles are congruent. So we can divide by 5, and we get 72 degrees, which means angle 2 measures 72 degrees, as well as angles 1, 3, 4, and 5. Okay, try this one. We have a pentagon there, 1, 2, 3, 4, 5 sides, and we're asked to find the value of x and then to find the measure of each exterior angle. Go ahead and pause this video and give it a try. Welcome back. Let's see how you did. If you wrote your equation to be x plus 2x plus 2x plus 4x plus 7 plus 5x plus 3 equals 360. Great job. If you solve for x and got x equals 25, and you did that right as well. Now we need to plug that 25 back in. So 25 times 2, this would be a 50 degree angle. This one would be 25 because it's just x. This one here would be double the 25, so another 50 degree angle. The one here, 4 times 25 is 100 plus 7. So this would be a 107 degree angle. And last one, 5 times 25 is 125. So that would be a 128 degree angle. And if you want to check your work, add all of those up and you will get 360 degrees. Ooh, this looks better than my writing it. Go. Tessellation of a regular polygon. So a tessellation, or a tiling, is a repeated pattern of figures that completely covers a plane without gaps or overlaps. And just think of tiling your floor. in the kitchen, let's say. Your kitchen floor is a plane, it's two-dimensional, and if you tiled it with a tessellation, it's a repeating pattern, and you don't want any gaps or overlaps in your tile. So think of a tessellation that way if it helps you. To form a tiling pattern, make sure the sum of the angles where the polygons meet is 360 degrees. So if you are using, let's say, square tiles to tile your kitchen floor, like these ones here, then the sum of the angles where the polygons meet. So this is where, right there, is where the polygons meet, 4 of them. And so that would be 90 degrees plus 90 plus 90 plus 90, which equals 360. If it was less than 360, you would have a gap. And if it was greater than 360, then one of your tiles would be overlapping one of the other tiles. So you want where the angles where the sum of the angles where the polygons meet to be 360 degrees. Here's another example. Let's say you're using subway tiles or rectangular tiles. Those three quadrilaterals meet right here. And so that would be 180 plus 90 plus 90, which is 360 degrees. So no gaps and no overlaps. All right, so check out this tiling pattern, and we're asked to say if this is a tessellation or not. Looks like one. I don't see any gaps or overlaps. What we can do is check that where those triangles meet, if the sum of those angles adds to 360 degrees. So let's zoom in a little bit. The picture's kind of small. And so this is the point where 4 different triangles meet. And so we're going to add up their angle measures. And these are equilateral triangles. And you guys know that equilateral triangles are also equiangular, which means that the 180 degrees is divided evenly by 3. So all of those interior angles measure 60 degrees. I'll put that on here like this. 60 degrees. All of these are 60. 1, 4, and 3 measure 60. And angle 2 is not an interior angle of the equilateral triangle, but rather a line, a straight angle measuring 180 degrees. So we have 60, 180, 60, and 60, which does add to 360 degrees. So we can say, yes, this tiling pattern forms a tessellation. And that will conclude our discussion on section 10.1. My name is Emigh. Thank you for joining me, and I'll see you next time for our discussion on section 10.2.